So, hello and welcome everyone to today's LeetCode challenge. And the question number we are targeting today is question number 1 to 1926, nearest exit from entrance in a maze. This question states that we have given a matrix of dimensions m cross n with this comma represent a dot represented as an empty cell and a plus represented as a wall, and we also have given a entrance r comma c, and from that entrance we can move one cell up, down, left and right, provided the condition that the cells are not walls and the moving cell, the cells are empty cells, and our goal is to find the nearest exit from our entrance, and we have to return the minimum number of steps in the shortest path from the entrance to the nearest exit. And if there are no nearest exist, so we have to return -1. Also, the entrance is not considered as a exit, like in this example this girl is standing at coordinates of 1, 0, and this 1, 0 is actually a exit, but our question states that no entrance is considered as a exit point, so this girl cannot exit from this point in this maze, so she will have to move towards right directions 2 units so she can exit from this gate. So we have to return 2 in this case, and in this case she cannot move in right direction because there is a wall, and cannot move in left, up and down because those are out of the bounds of this maze. So there will be no exit point for this girl in this maze, so we have to return -1. So let us take the constraints. M cross n will take a maximum value of 100 into 100, that is 10 to the power 4. So any solution that is big of n square will work here. And so what could be the intuition to solve this problem? The basic intuition to solve this problem will be like BFS, moving on adjacent cells and incrementing the distance value for every cell by 1, so we can move on every adjacent cell that is an empty cell with value incremented by 1 from its previous cell value. And whenever we encounter any border cell that is not an entrance itself, so we have to return that distance. So let us visualize our code. The code is pretty simple. This is a C++ BFS solution, and let us visualize our code by using example number 1. This is example number 1 given to us, and this is the matrix representation of this example number 1. This cross represented a wall, that means we cannot move into these cells. This circle represented our entrance. So first let us declare the directions for movement: left, right, up and down. Let us visualize these. If we are at r comma c and we have to move in upward direction, then the coordinates for the nearest upward or adjacent upward direction will be r minus 1 comma c. That means the row is decremented by 1 but the column is same. like this. If we have to move upward, this row is decremented by 1 but the column is same, and in downward the row is incremented by 1 but the column is same, and in right direction the row is same, like this is the same row but the column is incremented by 1, and in left the row is same but column is decremented by 1, and this is shown here. This is r minus 1 comma c, that means minus 1 comma c. This is 0 comma 1, that means same row but the column is incremented. Here the row is incremented by 1 but the column is same, and here the row is same but the column is decremented by 1, as stated by these DIRs. Now let us take the dimensions of this matrix n and m and declare a visited 2D matrix for this, that is initiated by false as firstly. Then mark our entrance points as visited, and this the entrance are 1 comma 2, so this is 1 comma 0 1 comma 1, and this is 1 comma 2, so mark this as true first. So let's mark this as true. This gets marked as true, and push these coordinates inside the QE with distance 0. So this is 0 distance and coordinates are 1 comma 2. The QE contains a structure as pair of integers of integers. So this is our D, and these are our R and C. Now let us check if Q is empty or not. No, Q is not empty, so take our D, R and C inside these three variables and pop out this from our QE. Make these R comma C as a vector and first check if this vector is not our entrance point. That means this could not be our entrance point, because we can see here that our entrance point is not considered to be as a exit point. So we have to check if this coordinate is our entrance point or not. If it is, so we could not do anything, and if it is not, or and with that it is a border cell, so we have to return our current D, and border cells are guaranteed by this condition, but with this we have to check if this is not our entrance. Now this if condition gets false here, so we have to move inside our for loop, and our new NR will be R this 1 comma 2 and our NR and NC will be minus 1 comma 0, that means this, so this will be 0 comma 2, and we have to check if this 0 comma 2 is inside the maze dimensions. Yes, it is inside the maze dimension. That could not be previously visited. Yes, this is not visited yet, and this could be a empty cell. Yes, this is a empty cell, so we have to first mark this as true. So let us mark this as true. Mark this as true. and push these coordinate inside the QE with previous distance plus 1. So we have to push previous distance is 0, so this time the distance will be 1 and our coordinates are 0, 2. Now our I is incremented and points toward this 0, 1, that means this, and our new coordinates will be 1, 3. This 1, 3 are 1, 3, that means this is inside our maze previously not visited, but this is not a empty cell. As you can see here, this is a wall cell, so this if conditions is now false, so this gets rejected and our I is incremented and points toward these new directions, that will be 2, 2, and this 2, 2 as well is inside the dimensions of this maze and previously not visited, but this is a wall and so we cannot move here as well, so these gets rejected. This is 1, 1, this is 1, 1 is this is inside the dimensions of the maze previously not visited, and this is a empty cell as well, so mark this as true. So we have to mark this as true. Mark this as true and push these coordinate inside the QE with previous distance plus 1. So the previous distance is currently 0, so this is 1, 1, 1. Now again check the queue is empty or not. No, queue is still not empty, so extract our D, R and C this time, and our D, R and C this time are these coordinates, and pop out this from the QE. So we have to pop out this from QE, and this time our coordinates for will be R is 0, 2, so this is 0, 2. Now we have to check if this is a border cell. Yes, this 0, 2 is a border cell, and whether this cell is an entrance or not. No, this cell is not a entrance as well, so we eventually found out our nearest exit, so we have to return the current distance, that means 1. So we will now return 1 for this test case directly, and we will further not check these conditions or all these remaining empty cells. So we have to return 1 here. So this is the very simple BFS code for this problem, and let us code this. First we have to maintain our direction vectors dirs -1, 0, 0, 1, 1, 0, and 0, -1. Let us zoom this so everyone can get a clear view for this. Now extract the dimensions maze.size. Now make a visited array to keep track of previously visited cells. Make a QE of pair of int the structure of QE will be like this. Integer to pair of integer. Now extract the entrance points R, C. Make them as visited first. Push inside the QE with distance 0. Check until the QE gets empty. Extract our current distance. Second pop out the current coordinates. Check whether the current cell is a border cell or not. By this, and the current cell will not be the entrance. If not, then return D. If it is, then we have to move on. The remaining DIRs with NR and NC, and we have to check that if these are inside the limit of this maze dimensions or not, and could not be previously visited as well. and the maze of this new coordinates is also a empty cell? If yes, then we have to first make them as visited and then push inside the queue with previous distance plus 1. And finally, if we could not find any exit point, then we have to return -1. So I guess the code is fine. So let us first run this and check if it is running fine or not. Yes, it is running fine. So let us submit this and check if it is correct or not. Yes, our code is correct, and I guess this is a very easy intuition to solve this kind of problem. And there are other problems on LeetCode similar to this problem as well, like finding the nearest one from a coordinate cell or from a zero cell as well. So the basic intuition behind this problem is BFS, because of the fact that BFS travels on adjacent cells first. So I hope you all find this video as a valuable video for you all, and thank you guys, and I hope you understand the concept here. So thank you so much guys, and keep learning, and thank you guys.